students. In today's lecture, we will see section number 1 from CHP 4101 paper, and section 1 is of Thermodynamics, part 8, and this is our lecture number 1. So, our chapter number 1 is just a revision or the recapitulation. So, in recapitulation, there are several points are included as system and types of systems, surrounding state variables, heat, work, and conservation of energy. That is the first law of thermodynamics. The basic concepts, then zeroth law, first law, work of compression and expansion, free expansion, expansion against constant pressure, reversible expansion, and next one is heat. And related to it, the points are heat capacity, enthalpy, then state functions and differentials, state functions, changes in internal energy, temperature dependence of the internal energy, temperature dependence of the enthalpy, then work of adiabatic expansion, irreversible adiabatic expansion, reversible adiabatic expansion. These points are included in the chapter number 1. And you have learned these points already. We will see just a revision. So, see what is meant by the thermodynamics. So, thermodynamics is the science which deals with energy and different forms of the energy. And this science is concerned with the ways in which energy is stored within a body. Energy transformations mostly involves the transformations of heat and work. Then the fundamental law is the conservation of energy, that is the first law of thermodynamics. And the law states that the energy cannot be created nor be destroyed, but it can only transferred from one form to the another form. As we know, the turbines converts the energy into the electrical form. Means there is a wind energy, electrical energy, mechanical energy, chemical energy, different forms of energies are there. So, we will see the proper definition of thermodynamics. Thermodynamics is the branch of science concerned with the heat and temperature and their relation to energy and work. It states that the behavior of these quantities is governed by the 4 laws of thermodynamics. That means zeroth law of thermodynamics, first, second, and third law of thermodynamics. Irrespective of the composition or specific properties of the material or system in question. Question means matrix or a mixture. So, here 2 types of bodies are taken in this diagram. One is hot body and another one is a cold body. Here, the heat is always transferred from the more hotter body to the colder body. And here, diagram is given of a working body. Here is a piston which applies the pressure on the system, and you know any system have a boundary and surrounding. So we will see this in this next slide. So system, surrounding and boundary. So system means what? A quantity of matter or a region in space chosen for study. So see, you have taken some liquid in a beaker. Then this beaker is our system and remaining part is the surrounding. So any quantity which is taken in a proper apparatus, this is our the system, and this is chosen for this study. So see, this bubble shows inside part of this bubble is a system, then remaining part than this bubble is the surroundings, and the outer layer of this system is called as a boundary. So surrounding means what? The mass or the region outside the system is called as a surrounding. Then the boundary, the real or imaginary boundary will be there, and it is a surface that separates the system and the surrounding. So this is an imaginary layer or a surface which separates the two parts, system and surrounding. So this is a boundary. Then types of systems. There are various types of systems are present. First one is open system. So see, open system in which both mass and energy can be transferred from the system to the surrounding. That means there is no restriction for transfer of mass and energy from system to the surrounding. An example of an open system is a cup of coffee or cup of tea. See here, energy can be exchanged, either it can be absorbed or it can be released. That means energy is transferred from system to the surrounding and vice versa. Then mass is also exchanged. So this is the open system. Then second one is a closed system, which is a type of a system. Now here, the closed system in which only energy can be passed from this selected boundary to the surrounding. Here, there is no transfer of mass from the system to the surrounding. So see, here only energy is transferred. This here shows there is a transfer of energy from system to the surrounding. And here the mass is not transferred. So this system is called as a closed system where mass is constant. An example of this type of system is a tightly capped cup of coffee. Then next type of a system is isolated system. Now see, the isolated system is a system which neither transfers mass from the system nor the energy through the selected boundary. An example of this type of system is the coffee in a closed, well-insulated thermos bottle, or the example is a thermos flask, in which the heat and mass cannot be transferred from system to the surrounding. So system is known as an isolated system. Then our new point is state, equilibrium and the processes. So what is meant by state? State is a set of properties that describes the conditions of a system. For example, mass, which is represented by small m, temperature T and a volume V. Means simply state means what? It is a set of properties that describes the conditions of the system. That means when there are two temperatures as a T1, T2, volumes are V1, V2, masses are M1 and M2. So this is a set. Then the thermodynamic equilibrium means what? The system that maintains the thermal, mechanical, phase equilibrium or the chemical equilibriums. These are known as the thermodynamic equilibriums. See, this diagram shows these states. Here, state 1 is here, M T1 V1, which represents a set M T1 V1, and here M T2 V2. So this is for state 2 and this is for state 1. So the group of a number of properties is called as a state. Then the process means what? The change from one equilibrium state to the another is called as a process. So processes are again four types: isobaric process, isothermal process, isochoric process, and the isoentropic process. So see, what is meant by isobaric? The isobaric process in which pressure is held constant. Isothermal means temperature is held constant. Isochoric means volume is constant. And isoentropic means entropy of the system is constant. So see, this is our system, and from here the pressure is applied. So initially piston is here. At that time volume is V1 and system is at initial state. As time goes on and we are applying the pressure by using piston, the volume is going to reduce to V2, and this is our final state. So initial state to the final state, there is a moment of the piston. That means obviously system is going to compress. So see, state is a set of the properties, as like we can say that pressure is P1, here pressure is P1 and the volume is V1, and here pressure is P2 and volume is V2. See, this is a pressure P1 and this one is a P2. So this is a state function. Then the prefix isobaric, isochoric, isoentropic, in which the iso represents, it is often used to design a process for which a particular property remains constant. A isobaric process in which the pressure is constant, that means delta P is equal to 0. So see, this diagram shows here volume is changing Vi to Vf, but pressure is constant. Initial pressure is equal to final pressure is equal to pressure. So this diagram represents delta P is equal to 0, or change in the pressure is equal to 0. Then the isochoric process, here pressure is changing on the y-axis but volume is constant. So this is the isochoric process, and this process is also known as isometric process. Then the isothermal process, a process during which the temperature T remains constant. And see this plot, here temperature is plotted on the y-axis and volume is on x-axis. See, here the temperature remains constant and volume is changing. So this process is a isothermal process. Then see our new point, the types of thermodynamic processes. The thermodynamic processes are again of four types: cyclic process, reversible process, irreversible process, and the adiabatic process. So cyclic process means what? When a system in a given initial state goes through various processes and finally returns to its initial state, the system has undergone a cyclic process or a cycle. So see this diagram. You know the pressure volume type of a diagram. Suppose see here P1, V1, T1 is there, and here P1, P2, V2, T2 is there. The system moves from this point to this and again comes to the initial point. This is called as a cyclic process. Then the reversible process, which is defined as a process that once having takes place, it can be reversed. In doing so, it leaves no change in the system or the boundary. Means when process is started, the object moves from one point to the another point and again it comes to its initial point. Then the irreversible process, a process that cannot return both the system and surrounding to their original conditions. We can say that this is a one-way process. Then our next process is types of thermodynamic processes, in which we have seen three processes, and fourth one is a adiabatic process. A adiabatic process that has no heat transfer, that is dq is equal to 0, and this heat cannot be transferred out of the system, and it is considered to be perfectly insulated system. Now our next points are heat, work and conservation of energy. So see, what is meant by heat? It is a form of energy which transfers without transfer of mass from one body to the another body, or between system and surroundings from higher temperature to lower temperature by virtue of temperature difference between two bodies. Means heat is one form of energy, and this heat or the energy can be transferred without transfer of mass from one body to another body, and it can be transferred from higher temperature to the lower temperature, and the temperature difference is more important. Then this can be abbreviated as Q, and its unit is joule. Then heat addition into system, it will be positive. When heat is removed the system, then Q is negative, and it is an extensive property and path function. The system which is a path function, it is not a state function. Then our next point is work. Analogous to heat, work is also a transient form of energy, which is observed when it crosses the boundaries of the system without transfer of mass. And again it is a path function. So work and the heat are the path functions which does not depends upon the set of variables as P1, V1 and T1. Then small work done due to displacement ds. dW is equal to F into ds. dW means change in work, F is a force, and ds represents the displacement. So total work done is given by equation W is equal to, integration goes from 1 to 2, F into ds. Then similarities between heat and work. Here obviously both are the form of a energy. Then both heat and work exist in a transit, and these are never processed, never possessed or contained in a system. Then both are referred to boundary phenomena. Both heat and work are the path functions and do not represent as the properties of the system. Then the first law of thermodynamics, or the energy conservation law. You know this very well. Energy can neither be created nor destroyed, but it can be converted from one form to the another form. And the first law of thermodynamics is applied to closed system, cyclic process. If a closed system goes through a cycle, the algebraic sum of the total energy transfer to it as heat and work is 0. Means when cyclic process is there, the change in heat and change in work is equal to 0. dq is equal to 0 and dw is equal to 0. And phi dq minus dw is equal to 0. This is the relation. Then the limitations of the first law of the thermodynamics. There is no restriction on the direction of the flow of heat. Heat can move to any direction. The first law establishes definite relationship between the heat absorbed and work performed by a system. That is, dq is equal to du plus dw. This is the first law statement. Then this first law does not indicate where the heat can flow from a cold end to a hot end or not. It shows only the transfer of heat from hot end to the cold end. Then, for example, we cannot extract heat from the ice by cooling it to a low temperature. Some extra work has to be done. Then, second limitation is, does not specify the feasibility of the reaction. First law does not specify that the process is feasible or not. Example is given. When a rod is heated at one end, consider a metal rod and heat is provided to one end of that rod, and then equilibrium has to be attained, which is possible only by some expenditure of energy. Means you have taken a metal rod and heat is provided from one side. Till equilibrium condition is attained, you have to provide heat to this rod. You cannot predict, the one end is much hotter and second one is less. Then third limitation is, practically it is not possible to convert the heat energy into an equivalent amount of work. So practically we cannot convert the heat into work, or the 100% heat is not converted into the work.